This is figure 14-17. It is also slide 79 if you want to look it up. And I'm going to blow it up so you can see it bigger. But this just is like is a summary of the immune response. So antigens, and they can be found on the surface of enveloped viruses. These little glycoprotein spikes that look like little blue popsicles. They're on the surface of two different types of viruses here, and then the little red antigens on the surface of this bacterium. So antigens that are non-self, that means foreign antigens, trigger the innate immune system or non-specific immune system, which involves complement, natural killer cells, macrophages, and then the antigens can also trigger the adaptive immunity directly, or macrophages can present the antigen on their surface and stimulate the adaptive immune system like that. So once the adaptive immunity is stimulated, the immune function begins with, so we have to look at antibody-mediated immunity first, because the activation of helper T cells. So helper T cells are CD4 cells, and they respond to antigen presented on class 2 MHC proteins, on antigen-presenting cells. Once they are activated, then they can also activate B cells, which will become plasma cells and produce antibodies. And then helper T cells are also required to activate the cytotoxic T cells, memory T cells, and regulatory T cells. So all of these are CD8 T cells, which will recognize antigen that's bound to class 1 MHC proteins. Let's see. All right, so that's a good summary to help you go over the different steps involved. Now, primary and secondary responses of the immune system. The primary response is the first response to the antigen, and during the primary response, it takes 1 to 2 weeks for the antibody levels to peak. But in the secondary response, the increase in IgG, immunoglobulin G, is immediate and higher than the first response, and so the second response it takes a lot less time, much less than 2 weeks, for the levels of antibody to peak. So this is why immunizations are effective, because vaccines trigger a secondary response when you are exposed to that antigen, so hopefully you never get sick from it. Hormones of the immune system, there's several different ones, and I'm just going to briefly go over them. Cytokines are chemical coordinators of defenses, and these are the 5 groups of cytokines. They're interleukins, interferons, which we have covered already, tumor necrosis factors, TNFs, phagocytic regulators, and colony stimulating factors, or CSFs. For interleukins, they're the most diverse and important chemical messengers in the immune system. And interferons are important in viral infections. Tumor necrosis factors slow the growth of tumors and kill tumor cells. Phagocytic regulators coordinate phagocytic activity. And colony stimulating factors stimulate the production of blood cells in the bone marrow and lymphocytes in lymphoid tissues. So checkpoint question 20. A sample of lymph contains an elevated number of plasma cells. Would you expect the number of antibodies in the blood to be increasing or decreasing, and why? So we would expect the antibodies to be increasing because plasma cells produce antibodies. This section just talks about how there are abnormal immune responses like autoimmune and allergies and immunodeficiency diseases like AIDS. With autoimmune disorders, they develop when the immune system mistakenly targets normal body cells and tissues. A couple of autoimmune disorders, there's a lot of different ones, but rheumatoid arthritis and type 1 diabetes. Rheumatoid arthritis, the antibodies attack the connective tissue around the joints. And in type 1 diabetes, the antibodies destroy the cells in the pancreas that make insulin. So these are both actually autoimmune disorders. And for immunodeficiency diseases, there is SCID, which is severe combined immunodeficiency disease. That's when there is no immune response at all. And then there's AIDS, acquired immunodeficiency syndrome. And that is a result of the viral destruction of helper T cells. Remember, if the helper T cells are destroyed, it shuts down the immune response because they are key to activating the B cells. Allergies are defined as the inappropriate or excessive immune response to antigens. It's also called hypersensitivity. The antigens that set off the allergic reaction are called allergens. There's a lot of different types of allergens. There are 4 categories of allergies. The type 1 category is the immediate hypersensitivity. It's the most common. Then you have the type 2, which are cytotoxic reactions, for example, the transfusion reactions. Type 3 are immune complex disorders, some kidney diseases. And then type 4 is delayed hypersensitivity, for example, poison ivy. For the type 1 immediate hypersensitivity, the person will produce large amounts of IgE, and that will cause them to produce histamine, and they will have inflammation, the signs of inflammation, which can cause various symptoms, swelling, hives, constricting of your airways. Antihistamines can work. But if it is a severe type 1, then the person can go into anaphylactic shock without being treated quickly. Some people who are allergic to nuts or nut allergies can be really bad, and also bees and wasp stings. So there are different people who have different triggers, but the anaphylactic shock is can be very, very dangerous. So stress and the immune response. Chronic stress causes the long-term secretion of glucocorticoids. And one of the glucocorticoids you might recognize is called cortisol, the stress hormone. And what it does is combined effects, but it lowers the person's resistance to disease. Now, a little bit on immunity and aging, and we'll wrap this up. When a person ages, their T cells become less responsive, and this may be due to the shrinkage of the thymus and reduction in thymic hormones. B cells become less responsive, and they produce antibodies at a much slower rate. And that is the end of the Chapter 14 recorded lectures.